This is the question from GATE 2015 question paper and the question number is 60. The question is, the entropy of a gas containing n particles enclosed in a volume V is given by S equals to n kb ln AV e to the power 3 by 2 divided by n to the power 5 by 2, where E is the total energy, A is a constant and kb is the Boltzmann constant. The chemical potential mu of the system at a temperature T is given by, there are four options. Mu equals to minus kBT ln AV e to the power 3 by 2 minus n to the power 5 by 2 minus 5 by 2. B option is mu equals to minus kb into T ln AV e to the power 3 by 2 divided by n to the power 5 by 2 minus 3 by 2. C option is mu equals to minus kBT ln AV e to the power 3 by 2 divided by n to the power 3 by 2 minus 5 by 2, and the D option is mu equals to minus kBT ln AV e to the power 3 by 2 divided by n to the power 3 by 2 minus 3 by 2. So in this question, the question is like they are asking about the chemical potential mu, and they have given the entropy of that gas which contains n particles in a volume V, and the entropy is given here as n kb ln AV e to the power 3 by 2 divided by n to the power 5 by 2. So let's start solution. So I am going to write here S equals to ln kb n kb, okay, n kb so entropy will be n kb ln AV e to the power 3 by 2 by n to the power 5 by 2. AV e to the power 3 by 2 by n to the power 5 by 2. Yes. So this is the entropy of the system, and they are asking about mu, which is chemical potential. So how to do that? Basically, there is a relation between the entropy and the Gibbs free energy, and the relation is like S equals to minus del G del T at constant P. So from that equation, where G is nothing but Gibbs free energy. So from that equation, S equals to minus del G del T at constant P, we can find the value of G, Gibbs potential, with the help of S. So what will be the expression for the G? G will be nothing but okay, so that will be G equals to minus S dt plus, let's say, some constant. Now you can see that the S, whatever it is given here, it is not a function of T. So if I just do the integration part, then it will be directly giving as minus S into T. So what is the S here? S is kb n then T ln what was that? AV e to the power AV e to the power 3 by 2 divided by n to the power 5 by 2. So this is the required expression for the Gibbs free energy. Now if I got the expression for the Gibbs free energy, then what will be the chemical potential? The chemical potential mu, and the Gibbs potential is related as mu equals to del G del N. So if I just do the derivative of G with respect to N, then we can get the required chemical potential for that system. Then our G is, I am just going to write here G again. G is N. There will be one minus kb T ln AV e to the power 3 by 2 divided by n to the power 5 by 2. So this is g. Yes. Now we have to calculate del g del n. So what will be the value of del g del n? Here you can see that there is one n is present here and another n is present here. It is nothing but the derivative of a and b. So how it will be, like at the very first I am going to differentiate this term, like that's why the rest of the term will be like that, av e to the power 3 by 2 n to the power 5 by 2. So this is the first term derivative. And now the second term derivative. In the second term derivative you can see that the minus will be there as well. Then n kb t. Now ln x. So ln x means 1 by x. So that means 1 by av e to the power 3 by 2. And then here it is n to the power 5 by 2. Now it is not one, I mean it will be that after the derivative it will be like minus 5 by 2 n to the power minus 7 by 2. So that will be the required expression. Now if I just simplify that one a little bit, then it will be kbt ln av e to the power 3 by 2 divided by n to the power 5 by 2. And now here minus and here minus, it is coming as plus 5 by 2. Then kbt. Okay, now here we can see that there will be, oh yeah, so that will be like ln x 1 by x, and as a whole there will be this function as well. So that means av e to the power 3 by 2 will be in that expression also. So now you can see that this whole term will be cancelled out with this one, and here it will be like n to the power 5 by 2 minus n to the power 7 by 2 plus 1. So that means that it will be like n to the power 7 by 2 and n to the power minus 7 by 2. So as a whole it will be 0. I mean like n to the power 0, which is 1. So there will be nothing there will be no term in this there will be no other term other than kbt in this case. So that will be 5 by 2 into kbt. Now if I just simplify it a little bit more, then it will be like minus kbt, and then I'm just going to do a simple mathematics here, and then it will be like 5 by 2. So this is the required expression. Now you can see here our chemical potential, I can write it as minus kbt ln av e to the power 3 by 2 divided by n to the power 5 by 2 minus 5 by 2. So if I just match this one with the options given in that question, then it is like very much equal to option number A, minus kbt ln av e to the power 3 by 2 divided by n to the power 5 by 2 minus 5 by 2. So the correct answer will be option number A.